Hello, everybody. Thank you for joining me today. Today should be hopefully an interesting and fun one. If you're not familiar with me, my name is Mark Mandel. I do developer advocacy for games at Google Cloud, I should say. But mostly I work on open source tooling for games, which is lots of fun. Today I'm going to have lots of fun in that I broke stuff and now I need to fix it. It's a short answer. But I don't know what I broke or how I broke it, so I figured I would see what happens. Does that sound like fun? So, to set some context for what actually happened yesterday, so I've been working on this pull request. If you're not familiar with GitHub, pull requests are basically like saying, "Hey, I would like you to make these changes." In some ways, it doesn't matter. So what I'm working on at the moment is basically when we have fleets of game servers, so we have like a whole bunch of different game servers. When we scale down those game servers, we want to prioritize which ones we remove. Basically, we just want to, in this particular strategy, actually, we want to remove the game servers that have the least number of game servers on the particular machines they're on. So like if you had like five, and three, get rid of the ones with the three over here. Anyway, going through reviews. I'd already passed our build system. Everything was fine. Had some really good comments from some of the people in the community, and it was great. And what was it? Actually, it was this one. It was Eric here. So he made a really good comment about a particular thing. I could actually get rid of a section. And I was like, sweet, awesome, this sounds great. And I did that, and it looks like it should have been fine. All my unit tests pass. That's fine. But then we get to here and right, like this thing just dies. And we get a huge log of all sorts of stuff. But what happens down here? So basically we have this suite of end-to-end tests that happen. Here we go. Test autoscaler stress create. That looks like that has done weird stuff. And I don't know why. So we're gonna find out. I have some theories, just because I have seen a test that failed. Yeah, something around failing calling admission webhook, this kind of stuff. But we're gonna dig into what's yeah. See, and then just everything falls apart, and there's all this bad stuff that happens. And ew, badness. Okay, so it's like bad, right? Bad things happen. All right. So why did this fail, and can we make sure that it doesn't happen ever again, which would be ideal. Now, I'm lucky in that I actually have direct access to our build system, so I can actually pull that up, and that makes things a little bit easier to see from the build system. Not everyone has access, which is why we push the logs out. And then, okay, so you can see here, right, like, so we do a bunch of setup stuff, and we lint, and we run our unit tests, and here we do the building of everything, and we push it up to our cluster. So we have a Kubernetes cluster we're pushing up to, and here you can see we run our end-to-end test runner, and like that, it dies hard. What actually happens is it gets killed after 10 minutes, which is a whole other thing. And usually our end-to-end tests run probably about 3 minutes-ish. So yeah, something pretty seriously bad just went blew up hard. I have a couple of options. I can try and what's the word I'm looking for? Redo this on my own cluster. I could do it that way. That could work too. But I think what I'm going to do first actually is I'm in the Agones project itself. I'm going to look at the logs of what's currently running inside the Agones project to see what's going on. So we're actually going to dig into some of the logging stuff that we have built in here on Google Cloud. But more specifically, I think just also, where are we, Kubernetes? Just look at sort of how we can debug Agones and how we want to do that. So we have this cluster. This is what we run all our end-to-end tests on. It just sits there and waits for stuff to come in, and then deletes what it's done. Now, what we can actually see, so when you install Agones, see there's like leftover stuff here that needs cleaning up. When we install Agones, it does install this thing called an Agones controller. It's just a binary that looks for changes and basically does the Agones work, right? And these are some pods that are left over from basically the game servers left over from end-to-end testing, which didn't get cleaned up very well. So what we can do is actually dig into the logs here, and I have an idea, which is this is actually a nice way of doing this. So I'm going to go into the container logs, and so we can actually see everything that's happened because it picks up everything for, I think it keeps it for about 7 days, I want to say. There we go. So let's actually, no, I want this. Yeah, that's fine. All right, so we can see that a bunch of stuff happened, but what we want is actually severity equals error. Let's do that. Submit the filter. Let's have a look. Let's see if there's anything that particularly, yeah, see, when was this? This was, what's the date today? Today is the 30th. This is today. Yeah, see here. Okay, so I've had this happen before, actually. Load newer logs. Let's have a look-see. Right. This is actually tricky because it doesn't scroll. Here we go. View. Nope. I just want to actually make this box smaller so I can reach it. All right. It's fine. This here is, okay, so let's actually have a look. So we can actually see the errors that have come through. Make error updating status on game server fleet. I have a feeling this is actually a red herring. Yep, that's okay. So that's actually a normal thing. That's fine. That's a pretty normal thing inside inside Kubernetes itself. So actually, what happens here is that if it tracks like basically object generation inside Kubernetes. So if you've got an object like a resource and you're like, I want to change it, and it's like somebody else has already done it, it won't let you, and it kicks you back out. And you're like, okay, well then I'll just try again, right? There's a whole queuing mechanism. So that's sort of a red herring. That's fine. Let's have a look here. Where are we? JSON payload. Auto detection modified. Okay, cool. So that's fine. And so usually, like inside controllers, we could actually dig into that if people are interested. There's a whole queuing system. And what happens then is like it just kicks it out and then it tries it again at a later date. Now this is what I'm talking about. Cap out of range. Coroutines 159. I thought I had put stuff in place to fix this. Maybe I didn't. Maybe I did and then I got rid of it somehow. Let's have a look. Okay, but let's actually, I can show you exactly what it is. I know exactly where this is. Okay, so we wrote this function, filter game servers on least full nodes. So what I'm saying is give, is that a filter or is that a sort? No, it says give back. What does that even do? That's actually a really good question. Let's start there. Okay, so it's game server sets.go 9067. Oh, my fix is gone. Actually, well, that's fine. Let's stick through this. I'll show you why this failed. This is actually interesting Go stuff. Actually, no. Where are we? 67. Yeah. I had a fix for this. I don't know where it went. That's actually really interesting. Okay. I know what the problem is. Okay, we'll move on to other things then very quickly today, but that's okay. So what's actually happening is here. All right. So what this does, actually, let's back up. Filter game servers on least full nodes returns a limited list of game servers ordered by the nodes they are hosted on, with the least utilized nodes being prioritized. It's actually more of a sort than a filter in some ways. Now that I think about it, I'm actually wondering about naming on that, but that's a whole other thing. Anyway, so filter game servers on least full nodes. We pass in a list of game servers, a limit, which is how many we actually want. Or thereabouts. We actually often overshoot it just a little bit. We start a node map. Cool, that's all fine. And we go through it and we basically count up all the allocated game servers, make them ready, and then we sort the game servers by the nodes that have the least number of game servers on them. So then we have a list of stuff where like, okay, we can choose out of these ones to get rid of them when we want to scale down, which is useful. But where we're failing is here. All right. If we have a look again here, what does it say here? Error, runtime error, make slice cap out of range, right? The cap is the capacity. That's what they're referring to here. And so what is likely happening is that the limit is less than or equal to 0. Because I've actually seen this before. I thought this was going to be way more interesting, but that's all right. So we can actually I'll show you this in action. We'll actually it's play.golang.org. We'll actually do some fun stuff. So say for example, let's actually steal this. So we can see this happen. So we'll just say an array of ints, We want to have 10 and printf %-s %-v result for argument's sake, right? And that's fine. But what we might see is if we want to have, so what is this is the length, right? So this is we're making an array of ints, and this is when you want to do you want to create an array or some kind of data structure, but you want to specify the size or the capacity of it beforehand, which makes things a little bit more performant when you know what it is going to be up front. So we could say like make it a capacity of 10 with a length of 10, and we'll actually see that it's got like blank zeros all the way through. But if we tried to make it a length that's bigger than the cap, it tends to complain. Len larger than cap make, which is if we have a look at our log. Let's see, this says cap out of range, which is interesting too. So I have a feeling I know why that is. So if we made this 0, but then we said that was like -1. Negative cap argument. Interesting. Okay. I actually wonder why it says out of range. 0 maybe? That's fine. If we go 10. Len larger than cap. Okay, this gives us a slightly better error message. Maybe I've got an older version of Go or something, or a newer version of Go. But I have a pretty good feeling. Now, I swear I had a test for this already and I'd written a bunch of stuff. I swear I had. But clearly I don't know what I did with it. I'm wondering if I did something. I did something and it disappeared. In which case, let's just write it again. So let's write a unit test to see if we can replicate this, is basically what I'm thinking. So let's come in here, game server sets test. Cool. All right, so that seems, that's our test for it. We're gonna split this up a little. Oops, I can't spell. T.run. Just default. I don't know what I want to call it. So we're gonna create some subtests. I might actually pull this out from here. And see how that goes. So let's just run that. Make sure I didn't break anything. Make it all happy. Sweet. Passes. Excellent. Good start. Okay, now t.run, say negative limits. Let's see if we can replicate this. So -1. I just want to see if it panics. All right, because it shouldn't. Okay, complaining, actually. Okay, so what actually do we want here? So result is actually fine. Assert, we should just get back an empty value. Empty t result. That's what should happen, right? If we pass back in, say, like a negative number or anything like that, like it should just come back as a empty value, right? Nothing in it. And boom, cap out of range. Cool. Now we know why this is happening. Okay, so we can catch this. Because the nice thing that I think in here as well is if we don't have any game servers, then we don't have to do any of this work. In fact, we can skip all of it. So why don't we just do an early exit? I think that will probably be the easiest. If len greater than less than or equal to 0, return. We can actually just return nil. Oh, sorry, not len. Limit. And we can return nil, and we can return nil because nils get treated like empty slices, and they can get ranged on, and they shouldn't actually break anything. So let's rerun our test now. Excellent. What I will do is I'll actually add one more test too. I swear I fixed this actually. I actually remember hitting this specific problem previously. I swore I fixed it. I'm wondering if it's on my other machine, but if I pushed it up in it, right? I don't know. I did something went weird and I lost this, but that's fine. What I want to do now is actually, I want to push this as a 0 as well. Yeah, let's just make another one. Let's make another one called 0. Cool. All right, run the whole thing. Let's make sure that all runs. Okay. Excellent. In fact, let's just run this whole test suite here. Make sure everything's working according to plan. Excellent. Everything is working now. This is good. Okay, so I don't know how I managed to break that. I swear I'd run into this. Anyway. Oh well, we learned some neat things. So just T. So we'll go imports it. Make sure everything's all sorted the way it's supposed to. We'll also run our linter on here, which is the Golang CI lint, which is also super handy, and hopefully it won't find any issues. Let's have a look. I'm still like killing myself. I'm like, how did I lose this? But you know, these things happen, I suppose. Distributed version controls, like, what are you gonna do? It kind of sucks, but that's fine. Cool. That looks good. All right. Actually, I just want to git commit it because I'm just gonna push it in. Okay, so I'm just gonna push that up now, and we'll put it back through our CI system. So that takes about 5 to 10 minutes to run. Actually, it's probably closer to 10 these days. But hopefully everything should pass this time. So let's, so we'll see here, if I refresh this. Boom. All right, so that's starting up now. So we'll let that run in the background, and that's fine. What can we do in the meantime, actually? Okay. Nothing here that I can work on. Okay, that's totally fine. All right, so we will instead do some auto scaling work, I think. While it's kicking through, and we'll see whether that passes. The good thing is this is actually already approved. People have gone through it, and so actually we can merge that and have this ready to go. Basically, all the stuff we're doing is to do with auto scaling, which is kind of cool. All right, well then, while that's happening, feature, actually, do I have this as a branch already? Have I started this work? Nope, no I haven't. Okay, so I'm gonna do some work that's dependent on this work. So we will create a branch. GB is just git branch. Actually, git checkout -b. We'll call it feature autoscaler. That's based on this, and then we can always work from there. Okay, cool. So we'll have that run in the background, and we'll move on to some other things. Exciting. What we're working on specifically here, using the cluster autoscaler. We have a whole design ticket around this. So Kubernetes has this thing called an autoscaler. Cluster autoscaler, it's actually an open source project and what works across cloud platforms, or providers, I should say. It is actually kind of cool. Okay, so we're actually using the cluster autoscaler, and it's quite powerful, actually. I'm reasonably impressed with it. Originally, when we were looking at autoscaling nodes inside the cluster, we were like, no, this is not going to work. Oh, there's my dog. She has opinions. And what was I going to say? Suki, you want to come be on stream? See if she wants to come join us. Yeah, so this is actually really cool. So we wanted to take this and work on it. Basically make it so that we wanted to adjust some things inside of Agones so that the cluster autoscaler would work with what we're doing. Now, what's neat here is that it actually gives us some tricks. So what our strategy here is going to be is that we want our game servers to have annotations that mean that the cluster autoscaler can't delete them. Excuse me. So that, like the autoscaler, because that's something the autoscaler will do. Like it's built for kind of stateless workloads. So like if you have a web server, it'll be like, oh, well, if we got rid of this node, we would save a whole bunch of room of resource and memory, but we would need to kill this pod, which is running a web server, and that'll move it back onto the other nodes, right? Like, cool. For game servers, we really don't want to do that. But what we can do is, where are we? So here we go. Where are we? which version, best practices, running cluster with nodes. Now there's a thing in here which says, how do I tell it which nodes which can't be removed? Here we go. How can I prevent cluster autoscaling from scaling down a particular node? So you can actually set attributes on the node that will deliberately specify the node. But what you can also do, which is kind of cool, which I need to find the exact link to, which I probably have in the other thing. Here we go. Is what type of pods can prevent CF from removing a node, which is to say, pods with this specific annotation that they are safe to evict false, which means yay, right? We can specify that, which is exactly why we're doing all this work as well, to make sure that when you, to shrink the amount of space, or basically to pack, right, as many game servers into as few nodes as possible, so that what we can do is basically leave empty nodes sitting around doing nothing, which is kind of the point. And then the cluster autoscaler can scale down and remove those nodes. That's the theory. And then what that means is then you can actually just to increase the size of your cluster, all you do is you increase the size of your fleet, and to decrease the size of your cluster, you decrease the size of the fleet, and then you don't have to worry about trying to do both at the same time or anything complicated like that. You just have the one thing that you need to worry about. So first thing I want to do while we're watching that happen in the background is to keep an eye on that little yellow dot, is put this attribute on all the things. So let's do that. Well, I feel like we need to actually put it in several places. So what does our actual design ticket say? Here we go. We do need to mark all game servers not safe to evict. We also probably want to mark that Agones controller is not safe to evict. We really don't want the autoscaler moving that around. I think that's bad. So let's do that. So we're gonna start with that one first because that's an easy one. All we need to do is go into Helm and go into our templates. And we go into service accounts. Here we go. Here's our controller YAML, which is just a plain old deployment. Nothing special there. And where are we? Here we go. Okay, so this is interesting too. We've already, now I gotta find the right spot for putting it. And I think that is the right spot, or is it here? I think it might be here actually. Because actually, we can have a look. We can have a look, and we'll have a look at what's the deal here. What's the best way of doing this actually? kubectl get pods namespace. So we actually already set an annotation on that pod. Let's describe it. To set some values so that it gets reset. But let's have a look. Yes, this is actually the right spot. Yay! All right, so that does set a specific annotation. We do that if it's at all interesting. We do that because if we specify the annotation with the Helm revision in it, when we then go to, say, update a Helm script, it actually recreates that pod. So it deletes it and restarts it, which is really good because we dynamically generate certs with Helm as well. So it actually makes things a lot easier. So that should do that too. Okay, so here we go. Boom, boom, boom. So we're gonna add that to the controller. To test this, we have to build it. Because of just how make build. There we go. Make build images. All right, so we'll fire that off. That'll actually take a little while because that's to compile everything. That's just because our development tools work that way. So build images will build the images it needs for Agones, and then we'll tag them based on the commit value that comes through. gcloud auth docker means I can push up to our gcr.io, like our container registry, pushes it, and installs this particular version. Like you can see here, 0.6.0, that's the hash, right? That's the git hash for there. So that's going to run in the background too. So while that is happening, we can also do the other parts as well. Well, why don't we go have a look, and let's actually take a segue away, have a look at our pull request, and see if anything's happened yet. Just have a quick look. Nah, still pending. Okay, that's fine. Always good. Maybe you can even hear my fan going. All right, cool. Just wanted to see if it's going to pass. Then I'd be like, yay, awesome, we fixed the thing, and then we could actually make this approved, and that would be awesome. All right, so that's running the background, and we'll test that in a minute. What we'll do then is dig into the controller code where the pods get created. Here's an interesting question. So if we actually look at, say, there's kind of two levels to this, which I think are interesting. Bless you. There are two levels to this, which I think are interesting. So we have this type, game server, which is a struct. And when we want to get a pod out of it, we actually have a pod function. Where are we? There's a bunch of stuff in here. Here we go. Pod. Oh, excuse me. And this pod function is pretty central. And what it does is it says, okay, I'm going to create a pod for you, like a Kubernetes pod. And if anyone has questions, by the way, please throw them in chat. And an arbitrary length of sidecars, which are like extra containers that you could add to this particular pod. So you can add as many as you like. Just as a nice way of doing it. And there are most things, I would say, that happen in here. But there are some things that happen at the controller level. So where are we? If we have a look at game servers, controller, let's just go look for a pod. Here we go. Yep. So, right. So we create a game server pod. We have a sidecar, which is actually how we do our SDK integration. So there's like a little server that runs just alongside the game server. And what's someone call it? And my brain just fell over. And so like that sidecar dictates, like, for example, health checks. So we add the health checks to the pod from the controller because that's more of a concern of what happens externally rather than what happens internally inside the game server, what it's aware of. We do anything else to the pod from out here? I don't think we actually do. No, I don't think we do. I think here, we do a bunch of stuff here. Okay, pod scheduling is its own function, which is sweet. Pod scheduling. Actually, I feel like this is part of pod scheduling. So we have, that's actually a really interesting point. Okay, so we have two types of scheduling strategies, right? Like we have packed, which is like for cloud systems. So we want to keep it really tight. And then we have distributed, which is for more static systems. So like you actually want to spread your load out a little bit more. Distributed probably isn't going to run an autoscaler, or is it? I'm going to lean towards saying that let's say if it's packed, then let's add this. If not, let's not. I think that's okay. I think that's reasonable. Which also leads me to another thing, which is that we should make that other thing configurable. Something's really missing here. Actually, bear with me one sec. Docs. Scheduling, auto-scaling. Here we go. Packed. No, this looks right. Pod scheduling strategy. Okay, so that's all there. Okay. That's right. I thought I got rid of that to do something else that needs to get cleaned up. Was there any more lying around? Did I just leave any around? No, that's just one that gets generated. Okay. Bear with me. You know how sometimes you stare at stuff and you're like, how did that happen? Yeah, I think I need to have a look at what I did. I did something funny somewhere. Hopefully I didn't lose too much work, but I think it's fine. So pod dot object meta dot annotations, boom. There we go. So cannot use ball as type string. Oh, really? I have to use it as a string. I have to do it that way. Oh, interesting. Interesting. The things you learn. Okay, yeah, because annotations are a map of string. Yep, that's fair enough. So this, I'm actually trying to note this pod. This means that the autoscaler cannot remove this pod. Remove the node, I should say, that this pod is on. And evict the pod in the process. Cool. That seems reasonable. I like this. What we can also do is write a test for this, because we should. Defaults, scheduling is packed. That's great. Do I have one in here where I test for distributed as well? I don't think I do. That's not as fun. Okay, so we have a test, like, oh, that's applying defaults. Oh, I don't care about that. That's not what I care about. What I care about is test game server pod. Ah, perfect. So we create a game server. So we have a fixture. We get a pod out of it. Excellent. We had a look. Where are we? Now, pop policy static. We apply defaults. We actually need to do some tests for a pod that is packed, is not packed. Here we go. That's the sidecar. There's the annotations. Interesting. What is that? Now you actually got me wondering. Stable.group name container. Huh. What other annotations do we add to these things? Now you've got, like, I'm actually, like, this has been a while since I've looked at some of this code. Oh yeah, look at that, annotations, boom. The things. GSPod object meta. Okay, so that's already there. Configure the pod object meta details. Okay, so actually, you know what? I think I feel I put this in the wrong spot. This is pod scheduling. I'm going to actually remove it from here. I don't feel it's comfortable. Here we go. Object meta. Yeah, I feel like it should be here. Because it's if gs.spec.scheduling equals packed, then do these things. All right, cool. That makes me feel better. That makes me feel much better. Cool. Because here we're doing the pod object meta, and it's all in one place, and that's nicer. That's much nicer. This is just scheduling stuff. Yeah, that seems reasonable. That seems pretty reasonable. Cool. I'm not happy about this. All right, so we have test post scheduling. Okay, so that's not. Yeah. Okay. Actually, never mind. Do we have a test specifically for pod object meta? We do not. Maybe we should. Maybe we shouldn't. I'm not sure. Yeah, let's do that. Test pod object. Well, game server pod object meta t pointer testing.t, because that will also make me feel better. Cool. So actually, let's have a look. So let's think about this for a sec. So we're gonna have two of these. T.run packed and T.run distributed. Which is fine. We can probably reuse the game server. I think that's fine too. Game server pointer with a spec that has a game server spec and a strategy of which we actually will specify in the thing. Okay, and given that the function needs a pod, we'll create our own pod each individual time. Actually, we could. Doesn't really matter. Okay. So let's do it this way. Oh boy, some Kubernetes action. Yeah, a lot of it's just testing right now. Oh, actually, you know what? Ooh. Oh, I definitely broke something. Is that just an upgrade fail? All right, so I did some stuff previously. We might bounce back that for a sec. So I was trying to set an annotation, and it hates me. Read string expects dunk or dunk, but found F. Oh, I wonder if this is because, bear with me one sec. Here, this has to be false because it's a string. Let's try that now. Inside my Helm install. Let's see if that works. Something's maybe happening? That was what the issue was. Okay, so to jump backwards again, just for fun. So previously we had, Previously we had, okay, we're still online. Previously we had, what's the word I'm looking for? I don't know what the word I'm looking for is. Previously we had some, we'd installed this previously and we wanted to set this annotation. So let's see if that's still working. So if we Helm ls, that should be fine now. Cool. kubectl describe pod in the namespace of Agones, which is our controller. So we should see inside our annotations, cluster autoscaler Kubernetes safe to evict equals false. So we should also make that, what's the word I'm looking for? Make that configurable, essentially. That would be ideal. Does look like my bitrate has dropped a lot. I'm not sure why. My stream starts to die. Yeah. Oh, look, it's jumped back up. Okay, cool. That was weird. I just saw my Twitch stream do that, which is not what we want. Okay, looks like it's coming back up, maybe, hopefully, which should be good. All right, we will continue on. Okay, so that looks better. We should also make this configurable. Let's come back to this. Let's add a little to do. Let's solve one problem at a time. We're coming in here. Okay, so here. So gs.spec.scheduling equals packed. Pod equals a pointer to a core v1 pod. Sweet. Add pod. What was it? Game server pod object meta. Okay. gs.pod object meta. Pass in the pod. Does it return it, or does it just does stuff to it? All right, it just does stuff to it. So we can pod. Where's our tests for the pod? Oh, there's a bunch of interesting things in here. Okay, so we can actually steal a lot of this. Not all of it, but some of it. Object meta. Here we go. All this stuff here. Object meta, object meta, object meta. Yeah, sweet. And it'll actually be the same for both, so we may want to tableize this or do something fun more like that. Am I building a custom controller for your game server? Yes, I am. In fact, it's an open source project. If you have a look below, it's called Agones, and we've already built custom controllers for the game servers, and they're working pretty well, which is pretty sweet. So yeah, I'm working on some of the auto scaling stuff right now. But thank you for sending through questions. So let's have a look. All right, where are we? That's not a thing. There we go. Let's fix up some of these. Cool. All right, so that should be fine. That should be fine. That should be fine. Our thing doesn't have a name, so let's give it a name. Object meta will be object meta. This is where all the name stuff gets stored. Name will be John. No, actually not John. Lucy. That sounds better. John's too prevalent a name. Excellent. Great. And then, okay, so, boom. Okay, we may want to do that. Let's actually just run this test real quick, see if that's working. Yep, sweet, that all passes, beautiful. What are other things that get specified in here in the game server test? Let's have a look. Generate name equals, yep, that's the pod object manager. Generate name, namespace, blah, blah, blah. That all gets reset, that's fine. We could actually write tests for those too. Labels and annotations, so we do role label. Do we check the role label? No, let's do that. Assert dot equal tgs, not gs. What do we want? It's a pod dot object meta dot labels role label. Should actually, I should say that should be game server role label or label role. That looks like that should be about right. Make sure that's correct too. Beautiful. What other fun stuff do we do in here? Game server pod label. Yep, we got a test for that. Cool. Game server container annotation. Store the game server container and annotation to make lookup pod level easier. Oh, that makes sense. gs.spec.container. Okay, let's actually make that a thing. Container will be just random words. Goat. Assert.equal t should be goat. And how do I get it? Annotations. Here we go. It's actually going to give us lots more better testing. Not Mark. It could be Mark. It could be fine. I don't know. All right, that's all passing. That's beautiful. Okay, so the other thing that I want to test, which is the big thing. All right, so, and there's some, oh, interesting. This does the owner references stuff. Okay, so we do want to test that. So if you haven't looked at Kubernetes before, there's a whole hierarchy of ownership, which basically lines into garbage collection. So basically, if we specify that like the pod that gets created is owned by the game server, when we go to delete the game server, more often than not, you can configure options around it. Then what's the words I'm looking for? Then the pod gets removed when we remove the game server, which works quite nicely. So that all looks pretty good. And then since this is packed, gs dot, what do we, here we go. We want to check our annotations here. Pod dot assert, oops, sorry, assert dot equals t, we expect false. Should be interesting. That's a whole other thing. pod.objectMeta.annotations. Boom. Oops. There. Which is our safe to effect. So let's make sure that's true. Failed. Oh, because it's false as a string. Oh, and that's why. Okay, so actually, so I was like, why? Yeah. Okay, so it's false as a string. There we go. Now, this here is all pretty standard, and we want to be doing that for all the things. So I have a couple of options here. I could turn this into like a table-based test. I could also just turn this into a function and just call the function in both spots, which also is not terrible. I think I'm just going to call it into a function because it's just easier. Actually, boom, do this. Let's see if this works. Method. Nice. And we will call that. I'm actually just going to call it f because I'm lazy. But what I'm going to do is actually put it inside here and say f equals func. There we go. And so that will still work. So I could have gone the whole table-based route, which is actually really nice, and we do that in a bunch of places too, but sometimes this is just a bit cheaper and easier, because then it means I can also just do this, ftgspod, which is the standard stuff. Oops, I don't have a pod. If I did this. And setup and tear down on this is not like a lot, so, and then I can do this. That's an F, sorry. That should be blank, actually. And now that I think that all passes, sorry, that was packed and distributed. Let's run all of it. That did not work. Where did that fail? All right, I did stupid things. Oh, because I didn't actually change it. But even so, that should still be distributed. That should be fine. If I run that, does it pass? No, not equals blink. But if I run that, does it pass? Yes. I am now confused. Why would that fail? This is why we write tests, of course, though. Not equal to Lucy. Not equal to game server. What? What did I do? Okay. And this is why we live stream, because things go wrong and now we have to work them out. Okay. Scheduling equals distributed, which is fine. F. Mark? I am very confused. Yeah, no, very confused. These are running sequentially, so it's nothing like that. Could even do a. Why don't we even do this? See, that'll break, but I can do this. Okay, fixture.getCopy. All right, so we're always using our own individual copy. That passes. Deep copy. Distributed. That fails. What? Doesn't make any sense. What? What have I done wrong here? I don't know. Yeah, I don't. Okay. That's strange. So I have a game server. I specify pod. How does? Oh, Maybe I should have done this as table-based, because then I wouldn't have done a stupid thing like that and not actually called the function that I'm trying to test. That would explain a lot. Yeah, it would. Yeah. That all passes now. All right, but that's a better test. That is a better test. Okay. I'm gonna commit this. What's going on? Oh, did I hit that? Okay. That's quite funny. I'm just gonna commit this real quick. Fixes for. No, what am I doing? Adding labels to adding actually annotations. Annotations to all the pods. This is just work in progress commit, so I don't actually mind. I'll do horrible things to it. Okay. All right, so that's actually going to start putting those things in place. And then we have stuff that says annotations, and we can test this and see if it works. The thing I want to do is just pause for a sec, actually, because we do want to finish at some point soon, is to see whether my test passed from the thing that we finished earlier. And it has. That makes me very, very happy. I'm not going to merge this just yet. I'll tell you why. It's because I'm a little worried I left some code behind on another machine, and I want to go check that machine, but I don't want to do it while I'm sitting here streaming in front of everyone. So I will merge this later, but it looks like we fixed the bug that we found previously, which was panic in our system, which is not good. Panics are bad. We don't want those. Cool. So that makes me feel much better. I was worried about what was going wrong there. But we got to see some fun stuff in the process. All right, cool. How long have we got? We got like 7 minutes. All right, cool. Let's make build. Let me just do. Let's build this and push this up, and we'll see if we get some annotations on the things that we're making, which would be really nice. This takes a little while. So while that's happening, how do I want to distract you? That is a very good question. That is a very good question. Anyone have any questions for me while I'm building things in the background? Yeah, unfortunately I can't work on it. So I can't work on anything else. I can't like add another thing. The next thing I need to work on is updating Helm, which means I actually want to completely blow away our end-to-end test cluster. And recreate it and make sure all our scripts still work and make sure it installs all the things it's meant to install and do all the things it's meant to do. But it's getting there, which is good. Then I can update Helm, which then I can do some more Helm things. If you're not familiar with Helm, it's a package manager for Kubernetes. Basically, it allows you to install stuff on Kubernetes. Here we're installing like Agones itself. If you want to install through just a YAML file, you can totally do that as well. That's totally a thing. We generate both. So actually what I can do is while that's building is I can make gen install. That will actually use Helm as the templating engine to create an install YAML, so you can actually install that way too. So that's running. Boop, 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 boop. All right, so that would have put. All right, well, actually, I know what I can do. Oh, that's probably not a good idea. Well, I'll tell you what. Actually, no. What I can do is I'm going to install Helm. Hopefully, we won't break anything. It'll be fine. It'll be fine. Everything's fine. Shh. Controller. How do I want to do this? I wanted to specify, make it so that it was configurable on whether or not, the autoscaler was turned up, is just deemed necessary. So let's just call it safe to evict. Documents. Safe to evict false by default. And so this just becomes another option that people can make true or false inside their Helm configuration. How's that doing? That's just pushing stuff up. Okay. And apparently slowly because my bandwidth is really bad. Oh no, or it's back to being okay. I don't know. I don't know what my computer's doing. Sweet. All right, so we can document this. Save to evict. That is not in a format that we like. So let's make that camel case. 2 camel case. Oof. Much better. I love how IntelliJ does stuff like that. All right, so save to evict. Better. I wonder if we'll actually get this in there in time. Here we go. All right, so we have a bunch of stuff in here. Values.agones controller.resources. What does that do? Actually, yeah. Huh. There's so much stuff in here now that a whole bunch of people have done that it's kind of interesting to see. Like, you're like, oh, what does this thing do? Here we go. And this does need to be quoted. Yeah, so boom. Dot. Save to evict. Quoted. That should be right. So quote will actually make sure that the value has quotes around it. It's basically a function call. Values. No, that's not right. Actually, controller. That's where it is. Oop. Something happened. I wonder if that went through properly. Let's have a look. How long time we got? 3 minutes. Describe. Actually. Something happened. Here we go. Cluster safe to evict false. Okay, cool. That was fine. Awesome. So what we should see as well is kubectl. We'll just add a game server examples, simple UDP, game server.yaml. Seems like allocations should use label selection and not names though. I'm not sure what you mean, Jizelinski. Not sure. Allocation should use label selection and not names. We specify fleets. We pull stuff out of fleets. If that helps, I'm not sure. So let's actually describe the. So let's actually have a look. So kubectl, and we have a game server. Sweet. We should have a pod behind that, which we do. We describe the pod simple UDP. See if our annotation is there. Annotation stable. Nope. Cluster autoscaler save to evict is false. Sweet. Just in the nick of time, we managed to drop that in. Where's my thumb? My thumb is here. Excellent. Boom. All right. Let us commit that. And actually, I'm going to really quickly. I'm going to reinstall this super fast and just make sure that my configurable bit actually changed. Alrighty. Sweet, that's all clean. Alright, so let's actually just make that install that again. It should be fine. Make sure that's doing what I want it to do. Hopefully it doesn't fail. Boom, that looks pretty good. Let's have a look, which should be brand new. Namespace labels, evict false, and it should be brand new. kubectl get pods namespace equals Agones, which it is as of 20 seconds. Cool. I can't really think of another kube resource. Yeah, this works differently though. Like if we did it by selector, it would be bad. The short answer. Having fleet solves a lot of problems, very specific to our workload. Selectors would make this intensely more complicated. So I hear what you're saying, and I know exactly what you mean by like other things would use references to other objects. But in this particular instance, being able to reference a specific fleet makes things a whole lot easier. Maybe down the line. You don't want to select multiple things. You want to have control over what fleets you have. what, where, how they scale up and scale down, and some other bits and pieces. Yeah, because we're not dealing with stateless systems, it makes things really hard, or you don't want to accidentally pick the wrong fleet. Yeah, it gives you a lot of control. Anyway, but that's a good conversation. I think that's the end of things for me today. Let's actually commit this. Commit configurable safe to evict options. Cool. Actually, I'll push that to my GitHub repo. Awesome. Thank you so much for hanging out with me today. There's what was I going to say? Yeah, I'll throw this up on YouTube if you want to go back through it. You can follow me on Twitter @Neurotic or here on Twitch as well. Thank you so much for hanging out. It was fun trying to solve lots and lots of fun problems. What was I going to say? Yeah, I usually do this stuff 9 a.m. Pacific on Tuesdays. My God, my brain's not working. Every week I say I'm going to do extra ones and I don't, but I'll say it again because sometimes I do. And hopefully I will. I like to do some later in the afternoon sometimes. And if you like the Agones project, please come try it out, play with it. We're always looking for contributors and people to provide feedback and to dig through the code and all sorts of good stuff as well. Otherwise, it was cool hanging out with you all. Thanks for hanging out with me today. And at the very least, I'll see some of you next week. Maybe some spots in between then and there. All right, cool. Thank you so much, and thanks for your questions, and I will see you all later.